All right, guys. Very, very good evening, everybody, and thanks for joining in today with me. My name is Prateek Agrawal. I'm going to be the lead instructor for today's workshop, and we will talk about very fascinating topic. We will see how we can analyze Shark Tank data. Shark Tank, I'm sure everybody's aware of.
Yes, sir.
Correct. So Shark Tank, I'm sure everybody knows what Shark Tank is for. So Shark Tank is famous TV series, both in the US as well as in India right now, where people pitches ideas and seek investments from investors. So that's the TV series data that we will analyze today, but we will use very, very popular database language, which is called as structured query language. And you will realize that how easy it is to learn a new language and use it into practical use case as well. All right. So in today's workshop, a few things you can expect. I am going to explain you how to use SQL from scratch. All right. Second, we will use SQL, we will write SQL statements, but we will not install any software on our local machines. That means we will use software which is hosted on Google Cloud. So we'll use a software called as Google BigQuery, which is a very interesting and very easy to use SQL interface whereby you can run SQL query and you can upload your data sets, upload your tables, and analyze that using SQL query. And it's free for for trying purpose. So we will use that free version, and it's quite capable, and you'll be surprised how capable it is, even though it is free. So that's what you will expect. By the end of the workshop today, you should be able to run decent, or you should be able to analyze decent size of data using SQL scattered in multiple different tables. So that's what you should be able to expect today. Again, the assumption is that nobody knows anything about SQL. If you know something about SQL, good bonus for you. If you do not know anything about SQL, it's just all right. Just stay with me, and you'll be able to do all these things. And we'll also try and have some hands-on during the session today. All right. So what is SQL? Structured query language is also called as SQL. A lot of people pronounce it as SQL, but it's a language with database management software speak. And database management software are those softwares where you store data directly, right? So if you're using a Swiggy app or Uber app, when you place, when you order for a cab or when you order for food on any food delivery app, the data that gets generated gets stored in one of the database management softwares. So these database management softwares, where the data is residing in form of table, structured data is residing in form of table, you can directly query those tables using structured query language, because all the database management softwares, by irrespective of which company it is by, whether it is a Microsoft SQL Server, whether it is Oracle database, whether it is IBM DB2, whether it is some open source database management softwares like MySQL or PostgreSQL, all these database management software support SQL as one common language. And that is the reason why SQL is so famous, because it is universally accepted by different database management softwares, by different companies, and it is easy to learn, especially for any English user. It is used for sending any kind of instructions to the database management software, inserting data, extracting data, manipulating data from the database, and so on. Anything that we have to do with the data residing in tables of a database, you can do that using SQL. Analysts like you and me, data scientists, data engineers, anybody who's working with data would actually need to use SQL. Any software developer who's going to design an app which will store data or manipulate data will also need to have SQL understanding. Plus all the reporting tools as we know them, for example, Power BI, Tableau, Python, including R, SAS, Excel even, you can actually use these, all these reporting tools as well to write SQL statements. They all support SQL. And the reason why they support SQL is because these reporting tools do not have data in them. The data they get is from databases. So whenever they have to extract the data from tables of databases, then that's when they think of using SQL, because that's That is one of the easiest and universal way of extracting data from databases. So who owns SQL? Actually, it was designed by a couple of computer researchers working with IBM in early 70s, 1971 or so, but they made it open source for anybody to use. So no company really owns SQL now. It's just like any other language. But there is a body called as American National Standard Institution, ANSI, which kind of designs or which kind of controls the protocol of SQL language. Just like the de facto English language body is in UK, Oxford. So Oxford, every year they publish new set of words that they include in the language, in the English language, right? Similarly, ANSI is that body which kind of is the custodian of SQL language protocols, which most of these database management system roughly follow. So if you know SQL in one platform, you can use SQL in any other platform with minute changes here and there. Just like English, if you can speak English in one English-speaking nation, you can easily use it in several other countries as well. All right, so that's the introduction, guys. So that is what you can expect today to learn. Now, just a little bit about me. I've spent around 17 or 18 years in the data consulting industry. Started my consulting career in the US, worked with some of the big 5 consulting firms, consulting large financial clients on data management, data strategy management, and various technology related to data management and so forth. And more about me, if you want, you can definitely get connected with me on LinkedIn. If you just Google my name, Prateek Ivy, you will find me on LinkedIn. The first link that you will get will be LinkedIn. Instagram, also I'm there, but I'm very, very new to it, so I understand it a little less. But yeah, LinkedIn is something that I remain very, very active. So if you want to get connected with me, feel free to get connected. All right, let's get started. So as I said, I want to make it hands-on, and I want to make you understand SQL, not theoretically, but I want to make you understand SQL by doing it, by analyzing a live case. So since we spoke about Shark Tank, so we'll use the Shark Tank data, but where is the data? So for that data, right, so what I've done is that I'm going to send you a link and you can download that right away. So if you look at the chat window, I've shared this Google Drive link. Go ahead and download 3 files from this particular folder that I've just shared. You'll find there is a file called as episodes.csv, and there is another file called as pitches.csv, and there is a final file which says Shark Tank analysis scripts sql.txt. It's a text file, so you can open it in a text editor. All right. Now let's look at the tool or the user interface that we will use today, which is hosted on Google Cloud Platform to run SQL command and to create these, create a database and create tables in that database. Now, sorry about that. Can I ask for a volunteer? Can I ask for a volunteer? I'm going to make you understand how to use Google Cloud Platform and how to use Google BigQuery. So who can volunteer to share the screen while I explain you how to do it? Somebody who's rather new but should have stable internet connection. So who would want to volunteer? All right, let me see. Rishikesh?
Yes, sir.
Yeah?
Yes, sir.
Are you on a high-speed internet connection, Rishikesh?
Yes, sir.
All right.
Yes, sir.
Have you downloaded the Zoom app as well?
Yes, sir.
All right, great. Go ahead and share your screen, please. I could do it in my machine as well, and I'll do it at some point of time. But since I want you to also get a feel of it, and I want to give you an impression that it's not very difficult to use such cloud tools to do some basic work. All right, Rishikesh. So why don't you go to Google and just type what I tell you to type. Just type Google BigQuery. Go to Google, open a new tab, type Google BigQuery Sandbox. BigQuery Sandbox. Sandbox meaning a trial environment. BigQuery, yeah. BigQuery Sandbox. There we go. And when you get that, go to the second link. Go to this link.
Okay.
Go to this link. Now, rest of the folks, if you have two screens, you can try it right away. In one screen, you can see what he's doing, and the other screen you can try, or you can also try it after the session. The recording we will upload on our IV's YouTube channel. Now, scroll down. Scroll down. All these things you can read definitely, but I will go to directly to this Google, go to BigQuery. Now, this will end up opening a Google BigQuery user interface. This user interface will allow you to create a new database, allow you to import data from the CSV file that I've shared with you, and then we can run SQL. So just go ahead and accept the terms and conditions. You just need a Gmail account with it, and a non-work Gmail account. That means non-official. Your personal Gmail account would be better, because your official Gmail account may have some restrictions in it. So now this is a user interface of Google BigQuery. Google BigQuery is the user interface of the client to connect to Google Cloud database, which is a database which is inspired or which is a modified version of MySQL database. So now click on this dismiss. It says that, okay, you can give a credit card and start your $300 free trial, but we'll dismiss it. We don't really need this thing. So on the top right hand side, you will see a dismiss command. You can dismiss it. Rishikesh, on the top right hand
Yes,
side.
sir.
Yeah, perfect. Now, this is your SQL workspace, but right now there is no data in it. And where do we want to create the data? So just for a moment, just understand how it works. In Google BigQuery, the first thing that you need to do is that you need to create a project. Project is like a big folder. You can imagine it's a big folder, right? And in this project folder, we will create databases, which Google calls as Dataset. Databases can have multiple tables in them. So this is where inside this database that we will create, we will end up creating multiple tables. Is that making sense? So right now, we have to understand how do we create this project. So if you notice here on the top left-hand side, it says select a project. And on the top right-hand side, it says create a project. For now, if you select a project, there is nothing. There's no project that you have created here. So it's not going to show you any project. So you can click on cancel here. And then what you can do is that you can go to create a project on the top right-hand side. Click on create a project. All right. And when you click on the create a project, then here you will say that, okay, you have 12 projects for free, but you can request for more. And in one project, you can have a lot of databases, so don't worry about 12 project restriction. Okay? Now, this project name has to be universally unique, globally unique. That means the project name that Rishikesh will give, please don't give the same project name. It won't work. So go ahead and give a project name here. Rishikesh, maybe write your own name and write your favorite number after a hyphen. Don't put any space in it.
Yes.
And put everything into small case. Keep everything into small case.
Yes.
Project. I think the spelling is wrong. And you can't change it later. Okay? Once it is created, then it is created. Remember, it has to be universally global. So the name has invalid character because it does not accept any underscore. So remove the underscore. You can't have space in it. You can't have underscore in it. You can only have hyphen in it as a special character.
Yes.
All right. You don't have to give any location or any organization. Click on create now. So what we have done is, what Rishikesh has done is that he's just created his first project, right? And now it's being created. It just takes a few moments, few seconds to create this project. And once it is done, you will see a window like this where it says, welcome to Google BigQuery and so forth. Just click on done here. And on the top right-hand side, you can see that this is the project that got created, Rishi project 1, 2, 3, 4, and he can select that project, or he can also, by default, it is now the only project, so it is by default also selected. So you can see it is already selected. Otherwise, you could have gone over here, or you could have gone over here to select the project. Okay.
Yes, sir.
Now, if you notice, this is the Explorer window on the left-hand side. This is the Explorer window on the left-hand side. And in the Explorer window, you will find the project that you just created, right? Now, click on the drop-down right next to it. This drop-down. Yeah, perfect. Now, if you click on the drop-down, it doesn't show you anything. This external connection is just for nothing. So the reason why it is not showing you anything, Rishikesh, is because we have not created any database in it. Isn't it, Rishikesh?
Yes.
So the next
Yes,
thing that we want to do is that we are done with creating the project. Now, the next thing that we want to do is that we want to create a database or a data set. Now, first thing we will do before that is star it. Go ahead and star it so that it is pinned to your Explorer. Even if you create more projects, at least this project will definitely be there. Now, so we have started, and then there are 3 dots right next to this. Click on the 3 dots.
Yes, sir.
You will have an option to create data sets. So go ahead and create a data set. Now, click on the data set here.
Yes.
Right?
ID.
Give a name to the data set, and then name to the data set can contain these things: letters, numbers, and underscores. No spaces, no other special characters. Now, don't make call it a Shark Tank. Call it something as Shark Tank, and this doesn't have to be universally global. This has to be only unique within this database that we are creating. Perfect. Don't worry about location. So since we are using a cloud platform, so it is asking, hey, is there a restriction where you want to physically create it? In which data center? A data center residing in anywhere in the US, anywhere in the world, or in a specific region? Suppose if you were working on a government data and the government had mandated that the data should reside within India, within the US, then you would have selected that region accordingly. But here we don't really care. So let that be multi-region US, and then just click on create data set here. Don't worry about the other options. Now, what it does is that it creates a data set as well, or a database in this project. So this is your project. This is your database or data set.
Yes.
Now, within this data set, if you click on the drop down here, what would you find, Rishikesh? You'll find nothing, because of course we have not created anything. So what is the next thing that we want to do, Rishikesh, here?
Yes.
We want to do what, Rishikesh?
So we may add some data set in that.
No, data set you have created. So I told you, right? This is the hierarchy: project, data set, and then within the data set, we want to create tables. And
Yes,
tables are where you can actually see the data stored in structured columns and rows, like how we normally see in Excel, or normally you would have seen yesterday in the BI tool as well, right? So the next thing we want to do is that we want to create tables. So how do we create the tables? How did we create the data set? Similarly, we'll create the tables as well. So click on the 3 dots right next to the data set now.
Yes, sir.
And there you will find create table. This is one option of creating the table, or the second option is right on the top where it says add data. Go ahead and click on that, because that is pretty prominent. And we want to add data to this data set, right?
Shall I click on it, sir?
Yeah, click on add data. Now, when he clicks on the add data, he will see on the right hand side, he will see there is something called as source, right? Popular source, the local local file, Google Cloud Storage, and external data source. We will go to local file. Now, before we go to local file, have you downloaded the 2 CSV files, comma separated values file that I had given to you in that link?
Not it, sir. I'll download it, right?
All right. So go ahead and click on that. First, go ahead and download that file. I think it's over here.
Sir.
So he's copied and pasted the link that I shared. Now there are 2 CSV files which contain the data. One is episode.csv, comma separated values, and pitches.csv. Go ahead and download them. Right click and download. There is the last option, download. This also download. So now go ahead and open this file as well, just to see whether it has come properly or not. It's always a good practice before you import any data into a database as a table. Please go and check at least some part of the data, right? So if you notice here, we've got what all things here: episode number, pitch number, investment amount. And if you notice, in some of the places, the investment amount is 0, which essentially means that for that particular pitch in that particular episode, there was no investment made. Is that right, Rishikesh? If
Yes,
you notice here, there are some of them are 0 here, the investment amount, which essentially means that these pitches did not get any investment from any of the sharks. And investments in equity and investment in debt or equity percentage that they diluted. Anupam, Ashneer, Namita, Aman, Piyush, Vinita, Ghazal, these are all who? These guys are the sharks. Sharks or the investors who are there on the show, who listens to the pitches by different people and they decide whether they want to invest or not. So if it says yes or Y in front of a particular investor in a particular pitch, let's say, for example, this one, Ashneer, that means Ashneer agreed to invest in this particular pitch. Is that making sense? And also Vinita agreed to pitch in this particular, in the same pitch. Is it clear, Rishikesh?
Yes, sir. Yes, sir.
So this is your which table? Which table is this? What is the name of the table? Episodes. Got it?
Episodes.
Now we have seen the episodes table. Let's go ahead and see the pitches table, the next table that we downloaded, the second table that we downloaded. So now this is the pitches table, which has around 4 columns. You can just increase the size of the columns. Yeah. So if you notice here, and maybe you can zoom a little bit. If you notice here, we have pitch number, we have brand, we have idea. Idea is, what is the nature of the business, and the industry that idea or that particular business falls under. So for example, frozen momos is the idea by this particular company, which falls, of course, under food and beverages industry. And this is the common column between this table, which is pitches table, and the episode table. So if you notice here, pitches table has some data about the pitches, and the episode table also has some data about the pitches as well as about the investors, right? So, and the common column between these two tables is what? The common column between the episode table and the pitches table.
So what is the meaning of pitch?
Pitch is, have you seen Shark Tank?
Yes, I have seen.
So when they present their idea in front of the investors, in front of those sharks, that is called as a pitch.
Okay, I understand.
Right? In every episode, there are some ideas that the people pitch, right? Or people present in front of the sharks. So
right,
each such idea is called, presentation is called as a pitch.
Okay, sir. Thank you, sir.
So the common column between episode table and the pitches table is the pitch number. Right? Now,
Yes,
you
sir.
see, in the real world, this is a real life data as well. In the real world, we never work with a single table database. We always work with database which has multiple tables in them, because the data we end up normally grouping them based on the category. For example, let's say customers and the orders. So we will have customers which will contain customer information, and orders will contain all the orders information placed by those customers. For example, employee and department, right? So employee will have employee related information, and the department table will have department related information, and so on. Is that making sense? Yeah.
Yes, sir.
Now, that said, SQL or databases allow you to work with multiple tables very smoothly. And that is one of the powers of using SQL, that you can retrieve data from multiple different sources without having to do a lot of things, right? With very, very simple SQL statements, you can easily retrieve data from multiple data sources. That becomes a little difficult for tools like Excel or even Python and those kind of things. Here it comes naturally. When we work with SQL, it's very easy to bring the data from multiple tables, merge them or join them together. So that is one of the things that we will also see. So now we have seen the two tables, we have understood what the data is about, and now we are ready to import the data into the data set or the database that we already created in Google BigQuery. Let's go back to Google BigQuery.
Yes, sir.
All right, and here it says local file. Now that we have downloaded the files, the CSV files, so we will upload it by clicking over here. Now, just be careful about the screen, right? It says create the table by uploading. Of course, if you notice here, there are multiple options. If you look at the drop down, you can create an empty table, you can create a table from Google Cloud Storage or Drive directly, and so on and so forth. Different sources you can create the table, but we will upload it from a local file. So we'll just go ahead and select the upload option, and then select the file. Just so we'll browse to the file. So we'll upload first any one of the files, episodes file, let's say.
So pictures.
Or pictures is fine. Any one is fine. It's fine. Now the file format, it will automatically detect it to be CSV. CSV opens in Excel, but it's not a Microsoft file format. CSV file format is an open industry file format. It's not owned by any company. And that's one of the reasons why it is a preferred file format for storing the data, especially if your intention is to work on that file on different tools, right? So it becomes, because Excel files, you can't import Excel files in non-proprietary non-Microsoft databases easily. That's the reason why we try and prefer file formats which are open source. For example, CSV, JSON, Avro, ORC, Parquet. These are file formats which are open standard file format. All right, destination is fine. This is the destination, this project. And what is the data set?
Shark Tank, sir.
So go ahead and select that from here. Perfect. Now, the table is something that you have to give a table name here. So since we are importing which table? Pitches. So let's give it a name as pitches. Keep it everything in small case, just to be consistent. Because SQL is case sensitive in most of the database platforms. Pitches. Perfect. Now, let that be table type to be native table. Let that be native table is fine. Come down. One very important step we will take here, guys, and I want everybody to focus here. There is something called a schema. Schema is nothing but structure or skeleton, or in other words, design of the table. And when I say design of the table, as we have seen, a structured table has multiple columns in them, right? And we saw there were several columns in the pitches table when we opened it in Excel. So when you say schema and when you say auto detect, then what you're doing is you are instructing Google BigQuery platform that please read the data under each column and identify the type of data that resides in each individual column. For example, if the first column is pitch number, which is a numeric column, then please assign the data type as integer or numeric. If the second column is, let's say, idea, then that has to be text column. So go ahead and apply text data type. If the next column is a date column or a time column, please go ahead and apply the data type accordingly. So that means we are not being bothered about it. You're making the system or the system's artificial intelligence to please understand the type of data of each column and accordingly assign the data type to each column of the data. So that is what is happening by auto detect. If we do not do this, then we have to manually choose the data type for each of the column that we are importing. But it's Google BigQuery. They're pretty good with AI and so on and so forth. So we will go ahead and rely on this capability of Google BigQuery platform, and we'll say, hey, go ahead and auto detect the schema for me. So go ahead and click on auto detect.
Yes, sir.
And stop me, guys, wherever you do not understand anything. Okay, don't hesitate. Auto detect schema will be automatically generated. That means the structure of the table, that first column is the integer column, second column is a character column, third column is a date and time column, fourth column is a binary or true or false column. These 4 data types are common, right? Integer or numeric data, date and time data, text data or character data, and binary or Boolean data, which is true, false, or 1, 0. All right, good, great, auto detect, perfect. Now that's about it. Don't worry about the other option. Go ahead and click on create table. So now what's going to happen is in the same, so now it says load data created. And if you notice here, we have project, we have data set, and now we have a table, pitches. Go ahead and click on this table, pitches. And let's see what happens on the screen. So this is the working area. This is the working area, and you can see the schema. Schema is just the field information. So these are the fields. Pitch. What is the data type? Integer. Brand, string, idea, string, industry, string. Perfect. That's how it was. If you open the file again in Excel, you will see that that is how the data types work. Go ahead and open this pitches Excel file again. Here. Yeah. Go to this pitches. So if you notice here, the first one is integer, the second is text, the third is text, the fourth is also text, right?
Yes, sir.
Correct.
Great. Go back to Google BigQuery. Already. And if you want to preview the data, you can actually preview the data as well. Great. So these are the columns, and just click a cross mark here. And you can see the total number of rows inserted is 117. And you can quickly verify from that Excel file as well, how many rows were there originally and how many rows got imported. At times, there may be some problem, but here, there's no problem. I know that there were 117 rows in that particular table. So now, what are the things that we have done, Rishikesh? Can you summarize it quickly for me?
So first of all, we create a project in the Google Cloud, sir. Then after we create a data set, and in that we upload the table, pitches table in a data set called Shark Tank.
Perfect. So in order to create the project, we had gone to this option here. And then once we had created the project without giving any, and that project name had to be universally global, universally unique. And then what we had done was that we had created a data set by clicking on the 3 dots right next to the project. And then once we had created the data set, then we clicked on the add data here, and we followed the on-screen prompt, and we created the table, or we imported the table as the CSV table pitches over here. Rishikesh, I'll give you half a minute and go ahead and import the other table as well, the episodes table as well, quickly for me.
Yes, sir.
What is the missing here, guys? The table name. Great. And Rishikesh, just for my verification, what is the meaning of auto schema, auto detect schema?
So it helps to the, so it can
It identifies
BigQuery detects automatically
identify
as per
the
exactly the integer and the character words.
absolutely
types of the
identifies
data types.
the data type of each column of the table that we are importing and automatically assign the data type relevantly. Now, how do we verify whether the pitches table, the episode table that we imported is correctly imported or not? Click on the episodes table, perfect. It'll then show you the fields and the data types of those fields. Yes, these are all the fields. And then you can also preview the data as well.
Yes.
How do you preview the data? Perfect. And you can see, if you notice here, by the way, false, false, false. And if you go to your, your table, original table in CSV in Excel, you'll find that it had Y and N. Now, since we did Y and N, see here. So now how Y became true and how N became false. The reason why it became true and false, because remember, we did schema auto detect. So Google BigQuery has that intelligence that, okay, if it is 0, it means false. If it is N, if it means false. If it is no, it means false. If it is yes, 1 or Y, it means true. It has that kind of intelligence built into it. And hence it has assigned the data type to this particular field as binary. Is that making sense? And wherever it was Y, it had assigned as true. Wherever it was N, it has assigned it as false. Is that making sense?
Yes.
Go ahead and
Yes, sir.
go back to Google BigQuery. All right. Go to schema and verify the data type for these columns: Anupam, Ashneer, Namrata, Namita, and so forth. So if you notice, this is assigned as Boolean. Boolean is nothing but
Booleans.
binary: yes, no, true, false.
True and false.
Okay? Great. Now, what is it? The next thing that we want to do? The next thing that we want to do here is now we want to start analyzing the data, isn't it? Now, if you go back to that Google BigQuery, that Google Drive link that I've shared, there is a TXT file, a text file. Go ahead and open that file, please.
Yes.
Download this file as well and open it. So of course, it's going to open in a notepad. Now, go ahead and do a Control A and copy everything.
Yes, sir.
Go back to Google BigQuery. Now, if you notice here, was there a question, Sovik?
Yes, it's copied.
Sorry?
Yes, I have copied the note from the note.
Great. Now, if you notice here, guys, the next thing that we want to do is that we want to start querying the data out, extracting the data out, and we can start analyzing it. In order to extract the data or in order to read the data, we will have to start writing SQL commands. And now, where do we write SQL commands? So there is something called as query here. Do you notice here? There is query here, or you can click on a plus thing here and open a new tab. And when you open a new tab, this is a tab. This is the working area where you can write SQL commands, which are also called as scripts. Multiple commands form a script file. All right. Now, what you have done is that I've given you some scripts already, pre-written SQL scripts, right? Go ahead and paste.
Excuse me, sir.
Yeah. Go ahead and paste it, Rishikesh. Yeah.
Yes. Sir, is it same like how we use database management structure while creating tables and all that things?
We have already created the database and we have already created the table. We have already done that, Ashutosh.
No,
but
sir,
now
what I was asking that if in my syllabus I had database management. So when I was using SQL commands to create a table and all that things and link it to the PHP then. So is it same like how we do?
Similar. Yes. Similar. All right.
So thank you.
Great. Now, don't worry about these error messages and all that you're getting right now. Go at the top. Go at the top.
Yes, sir.
Now, you can zoom it by pressing Control and plus. Is it zooming? No? Yes?
Yes, sir.
No, it's not zooming, right? Control plus. Do you know how to zoom?
Window function plus can also.
Yeah, window function plus can also work.
Yes, sir.
Anyway, let me share my screen now. Okay, guys. So let's see here what we have. Okay. Um, okay. So I'm going to minimize this Explorer thing because I already have the, you can see the same data set, same table. So I'm going to just minimize this thing so that I have more space for showing you the queries, right? So this is how, so this is where, I've opened a new tab and this is where I'm writing the SQL statements. Now, when you write anything under pair of / asterisk and close it, end it with asterisk / inside this pair, whatever you write, it is considered to be non-SQL statement, considered to be a plain English statement, which is not considered to be an SQL command. So this is good for writing documents, writing notes, writing instructions. So it can be a great thing to just write notes. Okay. Now, SQL, as I said, is pronounced SQL or SQL and supported by all the databases. SQL statement are used for sending instructions. So one of the very common command that we will use in SQL is called a select statement, which helps you to read the data or extract the data from the tables. And then if you want to insert new records, if you want to update existing data, or if you want to delete existing data or delete existing rows, then you'll use delete statements. So these are some commonly used data manipulation language statements. And then we also have other commands called as create, alter, drop, grant, revoke, and etc. In today's session, we will of course not have time to go through all these commands, but you can easily Google and figure out that SQL statements are divided into 4 major categories: DDL statement, which are used for design purpose; DML statement, which are used for manipulation purpose; and select statement, which is the most commonly used command that is there in SQL, especially by data analysts and data scientists. So this helps you to extract the data. So DML is part of data manipulation language statement, and then there is DCL, there's TCL. I don't want to go into too much details on those right now, but you can definitely Google about it. Now, why is select statement most commonly used? Because as a data analyst, as a data scientist, as a data engineer also, you want access to the data in order to be able to analyze the data. In order to get access to the data, that means you want to read the data out, fetch, extract the data out from the tables. We just imported the data into the tables, right? Episode table and pitches table. Now, in order to analyze them, then you'll have to extract the data using select statement. Now, how do we extract the data using select statement? So this is a common template of writing a select statement: select, from, where, and limit. So we'll see, what happens in here. After from, we write the project name, the dataset name, and the project and the table name, the entire folder path for the table. Then if you want, you can write any conditions. And if you want to limit the number of records from the top, you can use limit to recorded, limit the number of records, restrict the number of records, and select will help you to select the columns. Let's see it in action. Okay. Now here, what I have written is select, and then I have written star. Star basically means asterisk, or is basically means that you're trying to select all the columns from which table. So you're trying to select all the columns from this project. My project name is this one, dot table name, project dot dataset name, and dot table name, project dot dataset name dot table name, right? And you want to limit the 5 records. So and how do you run it? And there is a semicolon at the end, right? If I select this entire thing from select star, from, and this, don't worry about these red comments, okay, which are under pair of / asterisk and asterisk / because they are considered to be comments. So now if I select it and if I click on run here, then what is going to do is that it is going to run this. And when it is going to run it, then at the bottom, you will see results. So you can see the results. Now, since I said, let's look at this command. I said, select star, meaning select all the columns from episodes table, where it was stored, project and this data set, and episodes table, and limit the top 5 records from the top. So it gives me, what has it given me? It has given me 5 records from the beginning of this table. Is that making sense? If you want, you can save this result as a CSV or into a Google Drive or into some other into Google Sheets or into copy to clipboard, that means you can copy this, you can go to Excel, and let's say you can paste it wherever you want to paste it, and then it'll paste the result as well. Okay, it may, so if you notice, you can paste the results also like this. So why this is allowed? So that Google SQL is great to fetch the data directly from the databases, tables, and from multiple tables, but it's not great for visualizing the data. So in order to visualize the data, normally we take the data extracted using SQL into a tool, BI tool, or reporting tool like Excel or Power BI or Tableau or even Python to do further analysis. Now, let's look at some more queries here, right? So the next question it says is, show the pitched brands from the clothing industry. Show the pitched brand from the clothing industry. By the way, this is also a method of writing a single line comment. If / asterisk and asterisk / was multi-line comment, and this is a single line comment. So hyphen, and then space. Don't forget to give the space, and then it's a comment here. Show the pitched brand. Now, if you notice the pitch brand, where are they? So if I open the table in Excel, if I go to the pitches table, and in the pitches table, if you notice, we have a column called as brand, right? And then we have a column called as industry. Then we have a column called as idea and the pitch number. So these are the 4 columns which are here. It says, show the pitched brands from the clothing industry. That means the industry column should be restricted to clothing, and then we want to see the brands from the clothing industry. So that means the query that I will write is select, and then I'm going to go to from. I'm going to come back to the column that I want to select from, and after that, now remember there is a project name, then .dataset name, .table name. But with Google BigQuery, one of the advantages is that since we know this data is residing in the pitches table, I can slowly write pitches and wait, and then it's going to show me the entire path. And then I'm going to just press tab, or I can select it over here. Now, under pair of ticks, tick is a symbol before number 1 in your keyboard, just below escape. Under pair of ticks, these are ticks. You can see the entire project name, and then the dataset name, and then the table name. Is that making sense, everybody? Now, as we discussed, select from where. Now here there is a condition. What is the condition, guys? Anybody, quickly? What is the condition here? What is the condition? What is the condition here? The criteria of the condition
is
industry.
so industry type is equal to clothing.
Right. So if I write IND, it suggests me the column, and I select it equals to under pair or double quotes. The reason why I'm putting under pair or double quotes, because it's a text field, right? And the value should be clothing. And then semicolon. Don't forget to write the semicolon, which means end of SQL statement, and go back to select and then mention the column that you want to mention. Earlier, we had mentioned star, but star is not a great practice to do, because for every report that we create, we don't necessarily need all the columns from the table. At times, we just need specific columns. So I will select specific column here. Let's say I will select here brand, and I'll wait, comma. That's how you separate the columns, comma. And then I will select industry. There we go. So we have selected specific columns, and I was doing select star, and I select this query, and then click on run. Select this query until semicolon, which is like an end of SQL statement, and run it, and it shows you the data. These are all the ideas, or all the brands from the clothing industry, as you can see. Let's go to the next query. It says also show the pitch number for these brands. So for this query that we just wrote, let me copy it. It says also show the pitch number. Right now, it is not showing the pitch number. Now, where is the pitch number for the brand? So pitch number is there in the same table, in the pitches table. Pitch number column is there. So what I'm going to do is, I'll come back over here and paste the same query. And then here I will write pitch, and maybe at the end, comma, pitch, and wait, pitch underscore number, as you can see, pitch underscore number, and then I'll select this, and I run it. Now it shows me the data, pitch number, industry, brand. Perfect. If I brought pitch number beginning at the beginning, got it? So it will show the pitch number first. Now let's look at the next question. It says, show the pitches that have been successful in attracting investments. Now, if you notice, guys, this query that we just wrote, it shows me the pitch number, it shows me the brand, it shows me the industry. But the next question says, show the pitches that have been successful in attracting investments. How do we know whether a pitch has been successful or not? So if you look at the pitches table, there is nothing about, there is no column information about investments at all. This is when you will go to the next table, which is your episodes table, and you will see and as you can see, there is a column here and there is a pitch number. Remember, pitch number is a common column between the two tables, pitch number. And then there is a column here called as investment amounts in lakhs in Indian rupees. Wherever it is greater than 0 are those pitches where one of the sharks, one of the investors agreed to invest. Is that making sense? One of the investors agreed to invest. That means we are interested in those pitch numbers or those pitches, those ideas where the investment amount column is greater than 0. That would automatically mean that those pitches were successful pitches, meaning they were able to attract investments from at least one of the sharks. So I go back to my query. Here, it says, show the pitches that have been successful in attracting investments. It doesn't say anything about a specific industry. So I'm going to remove this industries related to clothing. I would say, what column should be equals to what? Now, do you think that I can reuse this query, guys? First, let me ask you this question. Do you think we can reuse this query? This query is extracting the data from which table? It is extracting the data from pitches table, but the pitches table, this is my pitches table, does not have any information about investments. The table which has information about investments and has pitch number as well is this episodes table. Hence, we cannot reuse this query. Is that making sense, everybody?
Yes, sir.
Yes, sir.
Yes, sir.
I'll write select from, and then this time I'll write slowly episodes and wait tab, and then here I'll write where, and then I will write investment slowly, select this greater than 0 and semicolon, and go back to the select statement and select the columns that you want to select. It says show the pitch number, so I'll just want maybe pitch number comma investment amount, and then I select it and I run it. It shows me the pitches that had investment amount greater than 0, which means the pitches that could attract investments. Is that making sense, everybody? Now, for these successful pitches, it says for these successful pitches, also show the brand and the industry information. Here we are showing pitch number, we are showing the investment amount, but we are not showing the brand and the industry information. Maybe I want to create a report that would tell me the amount of the investments against the pitch number, as also the brand which pitched that idea and the industry that brand belongs to. However, the problem here is what? The pitches table contains the brand information and the industry information, and the episodes table contains the investment amount, which told us which pitches were successful. So we'll have to somehow join these two tables, merge these two tables in order to get column access to both the tables. Do you understand, guys? This is where this common column will come into the picture, pitch number. So using this pitch number as a common column, we will now join these two tables, right? And whenever you try and join two tables which have a common column, most of the and your objective is to find the common rows between them. Common rows meaning the rows where the common column have exactly the same value. If your objective is to find the common rows after joining the two tables on a common column, right, which is like finding, if you remember the Venn diagram in your school days. So let's say this is pitches table and this is episode table. These are the common rows or the intersection rows. Then this
Like
kind of an
joins.
operation, this kind of an operation is called as inner join or equi-join. All right, let's see how it happens in SQL. So since the query would require data from two different tables, episode and pitches, we'll have to join the two tables. To join two or more tables, we can use inner join, which is the most common type of join that normally happens in the SQL world. From, now this time, remember, we have to join the two tables. So we will say episodes from, so far we have been writing single table, episodes. And this time what we will do is that we will give episodes table, this big table, a short name, a nickname as E. Just a nickname I'm giving. Inner join. And I'll tell you why I have given that. It's not a mandatory thing, but it's a good thing to do. Pitches table as P. Right? So what I've done is that I've given a short name to both these tables, E and P. E is episode and P is pitches. And then I will say on, that means joining the two tables on the basis of which common column, on what logic. So on E dot pitch number. Now you realize why I gave the table name a nickname. The reason why I give the table nickname here is because if I had not given the nickname, in order to use the common column in my query, in order to equate it, I had to write the entire table name, including this project name, dataset name, and the table name. It would have been a big task. Whereas if I've given it a nickname with the help of as, then it makes our life much easier. I don't have to type in such a long thing. Equals to P dot what? Again, pitch number.
Investment amount.
All right. So this is how we inner join. Table from table 1, inner join table 2 on the basis of common column equating the common column. Is that making sense? Now, semicolon. What it does is that the moment you do an inner join or any kind of join between the two tables, you get access to columns from both the tables. And since we have equated the common column, so we are now interested in common rows between the two tables. And it said we are interested that we are only interested in those pitches which were successful. And what is the meaning of successful pitches? Where the investment amount is greater than 0. So I'll write a where statement. Investment is greater than 0. Right? Go back to the select statement. Now, remember, if you are going to use pitch number, which is common column between the two tables, you do have to mention the table name before it, or the table alias name, the nickname that we just created with the help of as. So here, it doesn't matter whether you do E dot pitch name, pitch number, or you do P dot pitch number because they're common. So E dot pitch number, comma, E dot pitch number, comma, what? E dot pitch number, comma,
Investment amount, perfect, comma, brand, comma,
Industry.
There we go. And then you run it, and you will now be able to magically see the data coming from multiple different tables. And that is one of the real power of using SQL. Here we have used only 2 tables. You could have inner joined more than 2 tables as well, very easily. So say, for example, these 2 tables are inner joined, and the result you could have inner joined with more tables. Let's say table 3 as C on the basis of whatever, right? And that process could continue. And that is a real deal breaker of real valid reason of using SQL or SQL when you're working with databases which have multiple tables, and the real life databases will have a lot of different tables. So you can equate them very easily, and the tables could come from wherever they are coming from, whichever data source. Alrighty, let's look at a couple of, I know I've passed through a couple of minutes, guys, but please bear with me for a few more minutes, guys, and it would add to your knowledge level, and then we'll be able to see. I'll give you some hands-on questions, practice questions to go back with. Now, let's look at this. How do we know the industry is preferred by the, how do we know, a little bit of bad English here. How do we know the industries that generally the sharks prefer? Basically, what we want to know is that, can we extract the number of successful pitches in each industry? So what I want to do is that I want to find out the number of successful pitches in each industry. That means I want a column called as industry, and then in the next column, I want the number of successful pitches in that industry. Now, industry information is there in the pitches table, right? And the investment, whether the investment was successful or not, is there in the episode table. Since again, we want the data from two different tables, so we'll have to do what, guys?
Inner join.
We'll have to inner join, right? Now we have already inner joined, so I don't want to write the query again. I will just copy this query, Control C, come over here, paste it from this as this, and feed that this investment amount is this. Now, remember, I want to find out the total number of pitches in each industry. That means I have to aggregate or group the data by something. Suppose if I want to find out how many females are attending the workshop and how many males are attending the workshop today. So what would I do? I will group you guys, right? I will first say that I want to I want to group the data by gender. Then I want to find the count. So if you think about it, if everybody was in like an auditorium, a banquet hall, not sure why it's not working. Let me do it over here. Let's say don't know how come. Anyway, so let's say if there were a lot of people in one banquet hall, so you would have said that, okay, these are all the people who are there in one banquet hall. Now, these are those people who are female and these are those people who are male. So first you would have grouped the data by gender. So group the data by gender. And then once the data is grouped, then you would have counted how many people are there in each gender. Same thing we will do over here in SQL as well. There is a clause called as group by. Group the data by which column? Remember, here we want to find out how many people are there, how many successful pitches were made in each industry. So we want to group the data by which column then?
Industry.
Industry. All right, group by industry. And then here, I'm not interested in seeing all these. I'm interested in seeing, by default, remember one very simple thumb rule. If you group the data by industry, after select, you can only print the column that you have grouped the data by. So here I will write industry, comma, and then I'm going to use an aggregate function or a group function. Just like Excel has count, Excel has sum, Excel has average or AVG, max and min, and so on and so forth. Similarly, SQL has also these functions available. So one of the functions that we'll use is count, and count function, and let's say pitch number, right? And so what this count, so how this entire thing will work. First, the table will open, both the tables will open. They will be inner joined on the basis of this pitch number. That means we will get access to all the common rows between the two tables and all the columns of information. And then it will filter all the rows where the investment amount is greater than 0. That means the successful pitches. And then the data will be grouped by industry. And then it will print industry-wise count. So this is the execution flow, guys, okay? From, where, group, and then select. And then when we write it, it'll show me the number of pitches, successful pitches in each industry. Number of successful pitches in each industry. Now here, if you notice, it comes as F0. Of course, it doesn't make sense. Here, the reason why it is coming as a random column, because this count E underscore pitch number is a derived column. It's something that we calculated. So we can write as, again, give it a nickname as total investments. Or you can write successful pitches. And then you can run this statement. Sorry, actually I forgot to select and run. So if you forget to select and run, then it will try and run all the SQL statements that you've written in this file. So I select and now I run it, and then you can see the result. Right? Now here the column name is coming as total successful pitches. Here, if you want to sort the data and see the pitches, or see the industry which had the highest number of pitches overall, then you can also sort the data. So how do we sort the data? So let's sort the above data by total number of investments in descending order, decreasing order. So there is a clause here called as order by. Order by 2. 2 basically means the second column after the select statement. 2 here would mean second column after the select statement. Either you can write 2, or you can also write that entire function again here, e dot pitch number. In descending order, decreasing order, that means the industry which had the highest number of pitches will come first. And then I select and I run it. And now you can see the successful pitches. So that means technology, food and beverage, health, accessories, clothing, these are the. Now let's do one more question. Just show the top 3 industries that have attracted the investments. Just show the top 3 industries that have attracted the investments. That means among these, I don't want to see all the industries. I just want to see the top 3 is technology, food and beverage, and health. So how do we limit the number of records in any query? So in order to limit any queries output, that means limit the number of records from the top in any queries, in any select queries output, you just have to use limit. So just write limit, comma, limit and space 3. That's it. Limit space 3 will limit the number of records from the top. Select it, run it. And you can see now these are the, and here you can also give it a. So it's pretty interesting now, right? All right, guys, thanks. So now you can see it's pretty interesting, and you can see actually that all the 3 are easily selected. All right, so far very easy. After the session, find some time, take a half an hour out, play around with the data, and you'll be very interested. It'll be very interesting for you. Show those. Now one last question, and then we will call it a day or call it a night. Show those industries, out of these industries, show those industries that have attracted at least 8 investments. Not among these are the top 3 in industries, but among all the industries, just show those industries which have attracted at least 8 investments. So we know that this clause had given, this group by had grouped the data, and then it would have given us industry wise total number of investments. If you simply write having and then use that count of e pitch number greater than equals to 8, having, that would actually give you, or that would put a criteria on the group data and give you only those industries which had at least 8 pitches. Is that making sense, everybody? So as you can see, it shows 8 pitches, or industries which have had at least 8 pitches. So the general construct of or template of a SQL statement or of a select statement is what? You start with select from, then you go to where, then you go to group. Then if you want to put a condition on the group data using one of the group functions like count or sum or avg, then you want to use having. Okay. And if you want to limit it again, so you can add limit. So limit will come at the end. All right. And we also spoke about order as well, which will help you to sort the data in descending or ascending order. So great, guys. Now, so we have seen, this is the, so far we have seen, this is the construct template. Select, from, where, group by, having. Having is to apply criteria on the group data using one of the group functions. Order by, limit, right? So this is the construct that we have seen. This, we write it like this, but the system runs it in different fashion. The system will first run from, and then, so first it will run from, then where, then group, then having, then it goes to select, then order, then limit. Okay, so execution steps are a little different. Now guys, some exercise for you guys. Okay, after the session is over, use the same data set, try to work on these 5 questions that I've given to you. Now, if you want answers to these questions, ping me on LinkedIn and I'll be more than happy to help you with the answers of these questions. My LinkedIn ID again is, if you go to Google and search for Prateek IV, the first LinkedIn account that you will get would be mine, and I'll be more than happy to be connected with you guys. Feel free to reach out to me for more such interesting use cases on of using SQL on real life data set. Plus, if you go to Ivy's YouTube channel, you'll find that it's my recorded videos only on using SQL to solve various different problems, real life problem statements from various different industries. You'll find data sets where I've used real life data sets from Zomato, from Uber, from last I think workshop that I had done was on layoffs that are happening. That happened in 2022. So very interesting use cases, and you can also use, now that you have learned some basics of SQL, you can also use these skills on different data sets and on your skills further. All these things that I taught here are fundamental concepts and significantly more number of things that we cover in my SQL classes, which is part of our data engineering and data science classes, guys. So if you are interested in making a career in the world of data analysis or data science or data engineering, then we have seriously successful courses. You may want to just reach out to us or go to our website and see some of the courses, or you can reach out to me as well on LinkedIn. I'll be more than happy to help you. Thanks a lot for attending today's workshop. I know I've gone a little overboard, but the recording of today's workshop as well as the data set would be available on Ivy's YouTube channel, which is youtube.com/IvyProSchool. So just Google Ivy Pro School YouTube channel and you'll get the link to our channel. I'll be here for the next 2-3 minutes if anybody has any questions. Otherwise, have a good night, guys. Take care, everybody. Take care, everybody.
Total, how many commands are there in the SQL?
How many commands? See, there are a lot of commands, but Souvik, just like, there are a lot of commands, and it also kind of varies a little bit from flavor of SQL to another SQL. However, the command that we use very often as a data scientist or a data analyst is select statement. If you're a data engineer, you would also be involved in creating databases, creating tables. So you'll also be involved with create statements and all of it. But a general SQL user should know these commands at least: DDL statements, create, alter, drop, truncate; DML statement, insert, update, delete, select; and maybe a little bit of TCL statement if you are in that kind of profile. Otherwise, at least DDL and DML statement every SQL user should know. So,
and so in actual job world, there's this kind of question we have to think from our end, or the higher authority will give to us.
There is no higher authority than you, Souvik. Don't think like that. It's always, all right, there'll always be some people that you will work with, so who you can brainstorm with. But when you actually start working, Souvik, there is no higher authority. Everybody is trying to solve problems. Nobody is going to give you questions in a platter, right? So you have to look at the data and you have to question yourself. Hey, if I was the owner, if I'm the CEO, if I'm the chief marketing officer, if I'm the chief HR officer, what kind of questions would I want to answer in order to help in my business? And automatically the questions will come. So,
correct, sir.
All right, guys. It was great interacting with you, and thanks a lot for participating in today's workshop. And I hope you guys had a good time in today's workshop as well as in yesterday's workshop, and the same data set on different tool done by Shani. So if you want to see that as well, please go to Ivy's YouTube channel and you can see that. Thanks a lot, guys. Thank you.